Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Summit Academy. In this video, we're going to be working on that Unit 3 practice test. And with this one, the first 3 questions are super simple because all you have to do is graph them out. So again, graph it out. Again, anytime you have the equations, you want to make sure that you're able to graph them. So it says the study of the equation, and we're trying to find what is the solution set to the equations. And what that means is it's where they cross or intersect. And the way I'm going to write it is I'm going to say one equation is going to be my left side. So everything to the left of the equal sign, so I'm going to say y equals, I'm going to say square root of 3x minus 3 plus 2. Again, make sure that plus 2 is on the outside of your square root symbol. I'm going to say my other equation, let's do it in yellow, is just going to be x minus 5. So my second equation is just going to be x minus 5. And so what I can do is I can type this into our wonderful Desmos calculator. So that's what I'm going to do now. I'm going to say, all right, I have y equals, I have square root symbol, so I can say click square root, I have 3x minus 3. Again, make sure you use that arrow key to be able to move to the right, and I need to say plus 2. So I have this function. Again, this is going to be our square root function, kind of like a teal color. And I'm going to have my second function, so I have x minus 5. So in orange or yellow, whatever you want to call it, that's going to be your second function. So be able to kind of drag and move your window around. Wherever those two intersect is going to be our answer. So we're going to say it's going to be our solution point. So we're going to have a solution point at 13, 8. So that's going to be our solution point. Again, if there's multiple points where they intersect, you want to make sure you're looking for those as well. But for this one, we can just say we have one solution point at the ordered pair 13, 8. So let me write that down. So let's say I have a solution. So solution at, I could say 13, 8. If it asks you for the x values, make sure you put the x values. If it asks you for the y values, make sure you put the y values. Because again, an ordered pair is going to be an x value and a y value. So make sure you're just saying that carefully. Alrighty, on the next one, it says for number 2, same kind of setup. It says study the equation, gives you a rational function this time because we have a ratio, and it says what is the solution to the set of equations, or what is the solution set of the equations. And so what I can do, same idea. I'm going to say one side is going to be one equation, but we're still going to graph it out. So one equation is going to be my left side, so I have y equals 3 over x minus 1 over x. Let me write it a little bit better. I write it like a normal fraction. So I have 3 over x minus 1 over x is going to be one equation, and then my second equation is going to be the right side, so I have x minus 1. So it's real simple. Again, be able to find where they intersect. So in my graph, again, make sure you clear out your graph. If you want to, you can kind of leave that initial point there as well. But I'm going to say, okay, I have first equation, 3 over x minus, let's say, 1 over x. And if I notice my window, I don't really see any problems, but I could say, I can hit that little home button, and it will bring me back to the origin. So I have my equation. My green equation is going to be our first one. The second one is x minus 1. So now I have 2 equations. Notice how I have 2 solution points, because if I'm tracing along and seeing, hey, I noticed that these intersect at 2 points. And so I can have my first point is going to be negative 2, negative 1 is a solution point. And I could say my other solution point is at let's say 2, 1. There we go. So we have two solutions for this one. Let me fix, so that should be flipped around. Should be -1, -2. There we go, a little bit better now. Let me fix this as well to have step for everyone. There we go. Okay, a little bit confused there, but we got it. Again, I knew that choice that I had originally was incorrect because I noticed that, hey, it should be on, you know, that intersection point. So it has to be touching at that point, and that other point was kind of over there. It wasn't where those two lines intersected. So it's almost like, you know, when you come to a crossroads, you're saying, okay, at what intersection are you on? And so you can find that point and find that label. So we're going to say for our answer, we're going to say, let's do, for this, I'm going to say solutions, because we have plural. So we have solutions at, and we would say -1, -2. Let me triple check again one more time. Yep, and 2, 1. 2, 1. And 2, 1. Be careful, it will sometimes ask you for the x value. So if you say your x values would be -1 and 2, and you can say your y values would be -2 and 1. But just make sure that you are finding those points. Again, make sure you're answering that question carefully. For number 3, same idea. It says given the function f of x equals x minus 1 squared minus 5 and g of x is -2x plus 5. Determine the x values of the points of intersection. So this is what I've been talking about. Get two equations. So I'm going to say my first equation is going to be f of x, and my second equation already has it broken apart, is going to be g of x. And then you're trying to figure out wherever they cross. Be mindful, it's asking for just the x values for this. So make sure that you just put the x values in your answer. So I'm going to go to my graph. Let's clear out some of these points. So let's say, let me clear out some of these for you guys. All right, so we're going to say we have f of x is going to be equal to x minus 1 squared minus 5. Again, make sure, take your time as you're looking for those lines. Make sure it is typed in exactly as it looks. So now I could say g of x is going to be equal to, let's say, -2x plus 5. You're going to be able to adjust your window. I have a couple functions here, and so what I can do is I can say, hey, scroll up, find your points, and I can say, hey, at these 2 points is where I'm going to have where my functions intersect. So I can say at, let me highlight these this time, so let's say negative, what was that, -3 and 11, and we had +3 and -1. So those are going to be your 2 solution points. Again, notice how they are where those 2 lines intersect. Again, find the x and y coordinates for both of those lines, and then we can say, okay, hey, what is going to be my x value for the situation? So let me write some of this stuff down. Again, feel free to pause, rewind, anything you need to at any time. So I'm going to say I have solutions, plural. I have solutions at, let's say it was -3, 11, and +3, -1. Again, make sure you're saying your ordered pairs are x and y, and so it's asking for just the x values. So I'm going to say x is going to be equal to, I can say -3 and +3. So be careful, make sure that you're only circling or only entering in what it asks for. So first three questions, super simple, graph it out. Wherever they cross is where you have your function. And so now for number 4, it says the company sells 2 electronic packages. It says package A contains 4 printers and 9 computers and cost $15,700. So let me write. So this is going to be let's say a system. It's going to be a system of equations. I kind of get that in your directions there. And so what I can do is I can do it like this. I'm going to write package. Let me keep reading actually. Let's say package B contains 10 printers and 30 computers and costs $50,000. Write a system of equations for the scenario and find the solution. So I'm going to say, let's do red for package A. So I'm going to say for A, I have or let's actually back up. Let's say, let's let X equal our printers, and let's say Y is our computers. And this is easy because I want to make sure I can graph it out and solve for this system. So I'm going to say, okay, what do I have? Well, I have 4 printers and 9 computers that their total cost is $15,700. So that's going to be my first equation. My second equation I can do in green. Let's say our equation B is going to be 10x plus 30y is equal to 50,000. And so we're trying to figure out, okay, where did these two lines intersect? So make sure you can go from your sentence to the equation, from the equation to the graph, and that's what we're going to do now. So I'm going to say my first equation was 4x plus 9y equals 15,700. Second equation was 10x plus 30y equals 50,000. You can notice how I might need to scroll out a bunch, and that's okay because we can find our point where they intersect. So I can say, okay, that's going to be my point where they cross. Again, it highlights it for you on Desmos, so it's really nice and simple for you guys to see. So I can say, again, at this point is where they cross, and so that's what I'm going to write down. So let me write some of this down. I'm going to say, here's our system that I asked for. We're going to say a solution is at 700 and 1,433.33. And what does that mean for our situation? Well, that just means that the printer, that just means this. We can say the printers are $700, and we could say computers are $1,433.33. So make sure you can understand what it is. If it gives you a scenario like a real world problem, you want to make sure that you can fill out and say what is happening. So we had our system of equations, meaning at least 2 equations. We had our solution point, and we said what it means for our problem. So for number 5, it says this. It says solve the equation for x squared equals 289. Again, make sure if this is your equation, make sure you're including both roots. So I'm going to take the square root of both sides. However, I have to say x is going to be equal to, I can say plus or minus 17. You could also write x equals 17 and negative 17. That would be totally fine. Just make sure that you are saying that it is both roots. It can't just be, if you just put positive 17, it's incorrect. If you just put negative 17, it's incorrect. You have to put that it's both of them at the same time. For part B, to solve the equation for x. And so what I can do is, first I'm going to set equation equal to 0. And so what I'm going to do is I'm going to subtract 17 from both sides. So I have 4x squared plus 13x equals, minus 17 equals 0. And now what I'm going to do is I have that equation, so I can graph it out. And then notice since it is set equal to 0, I can say my x-intercepts are solutions. So let me type it in like this. Yeah, I'm going to say, okay, I have my equation. I have let's say 4x squared. Then I have, hit that home button. There we go. 4x squared plus 13x minus 17. Again, notice I have my parabola shape, but more importantly, I have the 2 points where they hit the x-axis. So we're saying, what are the x values at these points? We're saying at when x equals negative 4.25 and when x equals positive 1 is going to be when our y value is 0. So let's say that. So we would say we have solutions at x equals negative 4.25 and positive 1. It's again super simple. Be able to identify that for yourself. For part C, we have to now rewrite the equation and solve for v. So super simple. Start with my original equation. So I have f equals m times v squared over d. Use those inverse operations. So use inverse operations to solve for v. So I'm going to multiply both sides by d because I'm trying to get this left side or this right side equal to just v. And this cancels out my variable d. So now I can rewrite it. I can say there's going to be d times f is equal to mv squared. Divide both sides by a coefficient m. So I'm going to say like this. I say m to both sides. So now this is going to be, let's say, I'm going to rewrite it like this. I have v squared equals, I have d times f divided by m. Last step, take the square root of both sides to get rid of that exponent. And so now I can say, all right, v is going to be equal to plus or minus the square root of d times f over m. For part D, it gives you some work shown, and what you're trying to figure out is where the mistake was. So for this one, we're going to say the mistake was in this step here. So mistake in step 2. We want to say, let's say, must be set equal to 0. To be able to solve for x using that intercept form, we have to solve or have to set it equal to 0. Otherwise, it won't work. And so what we're going to do is this. I'm going to rewrite what we have. So I have, let me actually select this and move it over, maybe. No. So now I'm going to say if my equation is 2x squared plus x minus 10 equals 0, I can type that into my wonderful graphic calculator. So I'm going to say like this, I have 2x squared, so let me square, there we go, 2x squared plus x minus 10. So at what 2 points do we have our x values? So we're going to say when x is negative 2.5 and when x is 2, we have solutions. So we say we have, let me do yellow, we have solutions at, let's say, x equals negative 2.5 and positive 2. For the last part, it says solve the inequality. So part A for number 6 is solve the inequality. And so I'm going to say graph the solution on the number line. So what I have to do, I have to use my inverse operations just like I'm solving an equation. So I subtract 2 from both sides. I have negative 6 is less than or equal to 3x. Divide both sides by 3. And I'm going to say my inequality is negative 2 less than or equal to x. Make sure you rewrite it so you want variable on the left. Make sure you're saying it's still saying that the x value is greater than, so we're going to say x is greater than or equal to negative 2. And this is really easy to graph because we can do it like this. I'm going to say, okay, I have my graph. I'm saying I have a closed circle. So closed circle on negative 2. And we're going to be shading to the right because we're saying any value greater than negative 2. So as long as the x is on the left, you know you can match your inequality symbol with the arrowhead. For part B, it says solve the system of inequalities and identify 3 points of the solution set. If you have the equation, graph, or inequality even, graph it out. And look for points in double shaded region. Because I'm trying to find where I have any points in those double shaded regions. So let me show you guys what I'm talking about. So I have my first inequality. I'm going to type them in as exactly as they look. So I need to have y, and then less than or equal to, and then I have 2x minus 1. And then for the second one, I have 3x plus y is greater than or equal to negative 1. So what I'm talking about when I say this double shaded region, notice how we have our shaded region in teal, we have the shaded region in orange, but we're talking about this double shaded region in here. So any of these points are totally fine. So for example, I could say 1, negative 1, I could say 2, negative 2, and I could say 3, negative 3, and that would be fine points. Again, anything inside of the shaded region, again, those ordered pairs is what we're looking for. So we're going to say some solution points could be, for example, again, there's multiple infinitely number of points, but I could say 1, negative 1, I could say 2, negative 2, and 3, negative 3. And those would be some examples of those solution points for this system of inequalities. For part C, it says write and solve a system of inequalities to model the situation. And so what I can do is I can kind of write out some inequalities first. So I'm going to say some information that I can use. It says they only have enough wood to make 30 chairs. So what I'm going to say is I can say for the first one, I can have x plus y is going to be less than or equal to 30. And then I can say if it takes 1 hour to make a dining chair and 2 hours to make a rocking chair. So I can say x equals dining and y equals rocking. That way we know. So it says takes 1 hour for each dining and 2 hours for rocking. And it says they have up to 40 hours. So I'm going to say 1x plus 2y is going to be less than or equal to 40 hours. It says they want to maximize their profit. Make sure you can write the equation as well. So I'm going to say for profit equation, I'm going to say P equals, let's say 60x plus 90y. And what you have to do is you have to solve for this inequality. So wherever these are equal to each other, I can take that value. So find max point of system. So I'm going to say in my graphing calculator, I had x plus y and then less than or equal to, let me double check, it was 30, this one, to 30, and then I said x plus y, 2y is less than or equal to 40. And so what I can do, I can find that max point. Again, that's where they intersect. So it's going to be at 20, 10. So that means when they make 20 dining chairs and 10 rocking chairs, they're going to have a max profit. So let me write that out. So we found a solution. So solution at 2010. And what we're going to do is we're going to take that value and plug it into here. So I'm going to take my equation. So I'm going to say 20 times. So we would say, okay, how many dining chairs? We would say 20 dining chairs and 10 rocking chairs. And then what we do for this one, we say 60 times 20 plus 90 times 10. Because we're plugging in each of those values for x and y, and we're getting our max profit. So we'd say if they use those two amounts, so if they make 20 chairs and 20 dining chairs and 10 rocking chairs, they make a profit of, so we'd say P is equal to $2,100. So be able to write your equation using the sentences, find the max point, meaning where the solution is, and we'll say specifically that is where they intersect. Write your profit equation and be able to plug in that max point into your profit equation and get your answer. Again, make sure you're studying for our Unit 3 test. Be sure to ask questions and stop by office hours. And as always, super slam that subscribe button.